What'd you do first? Okay, tell me how to factor. X squared. What do you get inside their parentheses? And then from the inside, you said you did X box? All right, let's do it. Good. Raise your hand if you got those two numbers. Jen, help us fill out the box.
The top left would be 3x squared. To the right of that would be 2x. Bottom left would be negative 9x. And then the last box is negative 12.
Good job, Jen. Ian, help us get the outside of the box.
Top would be 3x. 4 plus 1. X. Just X. And -3.
Good. Ian, multiply for us. 3x times x.
3x squared.
X times 4.
4x.
3x times negative 3.
Negative 9x.
Negative 3 times 4.
Negative 12.
Negative 12. So we're going to factor here now. 3x plus 4. Class, does order matter?
No.
Order does not matter of the binomials. Raise your hand if you factored. Okay, so why did I do these color coding on the side again? It's kind of like this. Once if I just said, given this polynomial, factor. This is what you would do so far. Does that make sense? Now to solve, Erica, what would I have to do next from here? Good. Solving, if you need to write that, set equal to 0. And the reason why is basically you're finding x-intercepts, your y value is equal to 0, right? So now I have x squared equals 0, 3x plus 4 equals 0, and x minus 3 equals 0. I'm taking each of these and setting them equal to 0. So, class, how do you solve for x? Rad. X is equal to 0. How do you solve for that one? Subtract. Now what?
Divide by 3.
X equals negative 4/3. And this one over here? X equals 3. Raise your hand if you got these three answers. The common mistake in solving is the coefficient here. So if you have something like 6 or negative 3x cubed, whatever it is, set it equal to 0 and it's going to tell you something. Okay? Alright, now that we've done basically all of this, let's go ahead and sketch our graph. X equals 0. Negative 4/3. As a student told me one time, they said, Mr. Ng, that's between -4 and -3. Is that true, class? No, it's -1.3, so a little bit past -1. Feel free to convert that into decimals, and then x equals 3. Okay. Put your finger on the 0 that has a kiss or a bounce. Should be here, yes? Okay, if you get stuck on that, let's make our chart. Remember last week we made a chart? X is equal to, and if you look ahead, you can kind of put them in order, least to greatest, because that's how you're going to graph, right? Left to right. -4/3, 0 and 3. What's the multiplicity on -4/3, Damien? Damien, what's the multiplicity of -4/3? Correct. Is that an odd or even? Shoot through or kiss? Damien, x equals 0? Yep. You said even? And what? Remember, if this looks weird to you, feel free to do something crazy like this. X minus 0 squared. Do you see it? You're like, Mr. Ng is not a binomial. We'll make it one. And then, Damien, multiplicity of 3. And we're going to shoot through. Henry, is this an even or odd degree polynomial? How did you know it's even? The leading coefficient will tell us if they're going to flip or not. But the even degree polynomial looks at the 4. He said the leading coefficient is positive, so it doesn't change. Even, start up, end up. Class, what's the easiest even we know? X squared, parabola. Does that make sense? All right, fun part, sketching. So at -4, we're going to shoot through it. At 0, I'm going to have to do a bounce or a kiss. And then at 3, we're going to shoot through. So there's our rough sketch of our polynomial. We factored, solved, and then we graphed it by multiplicity.